Welcome to talks by members of the Survey and Cartography section of the National Speleological Society. These videos are intended to be how-to videos on cave survey software and other programs used by cavers in the exploration and documentation of the world beneath our feet. So I'm recording now. Everybody should be on mute, and you can turn your camera off. There's no point in having your camera on because nobody's seeing you while we do the presentation. We can turn them back on during the Q&A at the end. But we are up to 29 participants right now. We might pick up a few more stragglers, but to try to be quasi-respectful of everyone's time, we're going to go ahead and get started. So our talk tonight is on an Introduction to WALS Cave Survey Data Management Program. This is a very popular tool that many large cave projects use to manage all their cave survey data and work through data management tasks and workflows of closing loops and bringing additional surveys into project-based caving. And so Peter Sprouse, who's, and correct me if I'm wrong, Peter, but I think you've actually been involved with WALS since the very beginning, or nearly the very beginning of it. So he can provide us with a great introduction and overview, as well as maybe some of the history behind WALS and the gentleman David McKenzie, who recently passed away, that was the driving force and author behind WALS. So with that, I'm going to turn it over to Peter.
Thanks, Aaron. Thanks for organizing these talks. Yeah, I'll start out just having a general discussion about WALS. As Aaron mentioned, I've been
don't forget to share
I guess
your
I'd
screen,
say a power. Yeah, I'll share my screen in here. I've been a power user of WALS, although it didn't have anything to do with writing any code for it. But David McKenzie, the author, was a good friend of mine, and whenever I had a request for a new feature, he was always happy to oblige. Since he passed away a few years ago, Andy Edwards has assisted with helping to keep the program going, and also it's been opened up to open source, and the code is up on GitHub. If anybody is inspired to try to improve the program, that would be great. For the time being, the program is continues to function well, and so I'm continuing to use it. I would say that the programs that are most comparable are that cavers use for processing survey data, at least in this hemisphere, are WALS and Compass. Probably Compass has some more users than WALS does, though it's a bit hard to tell. Other programs that are similar include Arion, Therion, Survex, that tend to get used in different areas by different groups. To me, the strengths of WALS are that it handles large data sets very well, and it also works very well with round tripping with Adobe Illustrator, and we'll be talking about round tripping more later on. But WALS has a lot of good things going for it. I really can't compare very directly between WALS and Compass because I'm not a Compass user. Other people know a lot more about Compass, and I'm sure that if they haven't given a presentation that they will be here. So I'm going to start out by showing, by demonstrating how to start up setting up a WALS file. And I'll show some characteristics of why it needs to be set up in certain ways by showing one of my ongoing projects here. And I'm going to share screen now. So any walls project, this one here is my my biggest one that I have, which is a ton of row caves. But you have a project tree, and I've just clicked on the root, which is a blue folder at the top of this project tree, and it has certain properties. So you can actually work just with a survey file alone, but you really want to start a project, and then you could put one or more caves under a project. In this case, there's a few hundred caves, but all projects have a title, which is like a description, and then a file name, which is limited to 8 characters. So this project is being described as Quintana Roo, but then it's QRPROJ is the name of the project file. And you set up a project file. The main critical thing that you're doing is setting the geographical reference. And what that means is it tells the program where your project is located on the planet. And it needs to know that so that it can do the magnetic declination on your survey shots. When you set your project up, you tell it where this project is located. In this case, this project is located in UTM Zone 16, but basically all you do is put in the lat long that tells walls where this project is located. When you do that, it's telling you that there's a magnetic declination of minus 1.8 degrees. You're also here at this point selecting what your datum is. So I'm going to X out of this stuff, and I'm going to start a new project. I just opened up one of my field books here. And so I'm going to go new project. And it wants me to give it a file name. I'll call it new PR. And it wants me to know where I want to save it. I'm going to create a new folder to save it in. Oops, caps lock is on. So oops, I haven't set up a new project for a while, so actually the file name is going to be new PR, and the title, which is description, I'll call it so I just created a new project. It has a file name and it has a description. Again, file names, WALS is an older program, so file names are restricted to 8 characters, which is actually enough. So I've created a new project and it has no caves in it yet, but it does have a project tree. So under the root folder, I can enter a new item, a new cave. And when this new item menu comes up, it can be either a survey file, a book, or other. I'm going to go ahead, just as an example, I'm going to create a book at this time. And this cave is, I'm going to give it a file name, and I'm going to call it Ensenada Area Caves. So I've created a book, don't have any survey data in there yet, but within this book, I'm going to now create an actual survey file. So I have a little cave here that I surveyed a few months back. And I'm going to give it its name here. I'm creating a survey file, description and name. So now I have, under this Cincinnati caves, I've got a new cave file here, which is empty. So there's WALS files. They primarily consist of your survey data, your from to station names, distance, azimuth, inclination, and various other things that you can put in there, like left, right, up, downs, and other things. But each survey file needs to have a few bare minimum lines of spacing out of the word, command lines in order to properly georeference a file, amongst other things. So I'm going to go ahead and put in a few command lines here that are the things that I typically use, and there's other command lines, but one of them is the date. In this format. And the other is, that's the date command. And then I'm going to put in a fix command, which is going to set the coordinates of the first station. In this case, it's going to be station 1 because I don't have any fancy prefixes for the station. And I'm going to enter that in UTM because that's the way I best remember how to enter it. You can enter it either in UTM or in lat long. So it's easting and then northing, which is going to be the case for either UTM or lat long. And one thing to keep in mind is, since we're giving the east coordinate first, it's actually going to be long lat, I believe. So what I put in here is I put in a command line that says fix station number 1 at easting of this number, northing of this number, and then elevation. In this case, this cave is at sea level. Finally, I'm going to go ahead and put in a units command line. I think that it might default just fine, but I'm going to put it in anyway. And that's going to be units order is distance, azimuth, vertical. So those are 3 command lines. And then after that, I'm going to start entering some data. I'm going to go 1 to 2. You can use enter or tab to go through those. I have a distance of 10.87 meters, an azimuth of 309.9, and inclination of minus 1.6. I don't have LREDs in this data, but if I did, that would be another tab line. So when I hit enter again, it's actually staying on the same line because it's ready for me to enter LRED data if I had it. What I don't, so I could hit enter one more time. It's going to automatically auto number the station if it discerns a logical sequence, and it can auto number forwards or backwards. But it will quit auto numbering if your previous line said something like 2 to 4, because then it doesn't know where you want to go after that. But station 2 to 3, 0.68. I'm gonna knock it off after 3 shots here. So I mentioned earlier that it's important to set your geographical reference in your project. And I'm going to go ahead and back up a few steps and do that right now. And so did just then was I clicked on properties, and then I have this menu come up. It's got 3 tabs on it. I'm going to click on the geographical reference. And also, this is where you can set your units, your review units to meet meters or feet. I'm going to click on geographical reference. It says right now the geographical reference is unspecified. That's logical because I haven't put anything in there. And so I'm going to select change here and pull this back over from the other screen. This is where I'm going to set the geographical reference, and I'm going to look on my survey book here. I could set it in either on the lat long screen or the UTM screen, and I'm going to set it at the same coordinates I had for the entrance. For some reason, Walls doesn't put a minus in front of the longitude, but it understands things, so that all works. I'm going to keep the datum here at NAD 83. So I've set the geographical reference for the project. So as you recall, we made a new project called SAC Sample Project. And on the project, we have a folder called Ensenada Area Caves with 1 cave under it. This geographical reference tells Walls generally where the project is located, whereas each individual cave in the project is also going to have some coordinates set. So there's 2 different coordinates typically in a project. One, the overall coordinate, and one, the specific coordinate for each cave. The overall coordinate is what Walls uses to adjust your survey shots to true north. And not all people adjust their survey data to true north, but the reason it's a good thing to do is, one, it gives you a true north arrow on your map, but also north changes over time. And if you have a project like Mammoth Cave, where they've been surveying for 100-something years, the magnetic declination may have changed several degrees over time. And in fact, if your project is in someplace like Alaska or Alberta, where you're close to the North Pole and you have a big magnetic declination like 20 degrees, well, that may change a lot faster than that. So the geographical reference that I set for the project is one that's going to be applied to all the caves in the project. So keep in mind that your project probably doesn't want to use that geographical reference for an area of more than about 30 or 40 kilometers, depending on where you are. So I'm going to hit, then there's important over here on the right side of this view here, it says derived from date. Yes, we want to do that. So we want the program to use date command line and these numbers in the geographical reference to rotate those vectors to true north. And when if you want to look at the coordinates of your survey stations in UTM, then you can also click this next box. And what that's going to do is, instead of making your survey relative to true north, it's going to make it relative to grid north, which is slightly different than true north. And I'm going to show you why it might be useful to have your coordinates in UTM here in a second. Hit OK. This project is ready to compile now that I've got the geographic reference set in these command lines. So I'm just going to go compile. And this has come up with 9 degrees up. I'm going to rotate it to north up. So here's your basic line plot. We can hit display map to see this line plot with its stations. Can also look at the profile view. I mentioned earlier about coordinates. you can go, and, this is sort of the main menu that you get after you've compiled your project. Over here under segments, there's a button called Details and Reports. And this is where you would export a shapefile, for example. Also, it gives the place to look at your coordinate listing. And I'm going to make a coordinate list here. And if you look at these coordinates here, they're in UTM. If I hadn't clicked on that button, make coordinates grid relative, the first station coordinate would be 0, 0, 0. So the reason this might be useful is if you were mapping in a cave, let's say you're in Mammoth Cave, and you've got a dome that's about to break out through the sandstone layer, and you want to know where to find that point on the surface, you would just enter the coordinates of that station into your GPS point, and you could walk to it. That's what's handy about having your survey stations shown in UTM coordinates. I should check chat here to see if anybody's got anything they want to know about here. Aaron, you know if we got any questions so far?
Yeah, I've been answering some of them in line as we go along. So we can
You
also
can always shoot one to me if you want to.
Yeah, and we can also come back to the Q&A at the end of your presentation too.
Okay, great. So, when you download walls, it comes with a sample project, which is called Kawa, I believe. And that sample project, when you open, it should open automatically when you first open walls. By the way, if you want to download walls, it's at the Texas Speleological Survey website. And if you just type in Texas Speleological Survey walls download, you'll get to that site. So walls comes up with a sample project, which was one of David McKenzie's projects. And he has some examples of pretty much all of the different command lines and different settings that you might ever utilize in walls. But you can also use the help button up here. If you hit the question mark, it tells you which release you have, and then you can also go to help comments. In this screen, you can do a search. Let's see. Let's go data format. And it's going to give you a bunch of different topics on data formats. Or let's say you wanted to put in survey. Let's see what that gets you. The general contents page has got, actually, I think help is not working on this. That might have something to do with some fixes that Andy need to work on. So, sorry about that, not working at the moment. Let's see. I'm going to, I think I'll move on to loop closure analysis. So in order to do that, I'm going to get out of my sample project here. We basically got through the basics of setting up your project. I'm going to open up my Quintana Roo project, and I am going to recompile. If from time to time you might have a problem with your data getting a little bit unstable, And a bailout from that is under Edit. You can recompile or purge branch work files. Those all get you back to square one, but I'm going to hit recompile here. You can see down here that was 339 kilometers of survey in this project. And if I zoom in, you can see that there's different caves here. The little squares represent the fixed entrance stations for several hundred caves. One thing that WALS requires is unique station names. So you don't just put a bunch of caves in a project, call them station 1 to station 2, station 2 to station 3 in each one. If I open up some survey data here, you can see that, like any big cave project, these stations have a prefix in order to make this unique. There's workarounds if your station names aren't unique. You can assign a virtual prefix by going up to, like right now I have, I'll just highlight this one cave here. Go up to Properties, and then I can go to Compile Options, and I can basically, at this point in my project tree, I can apply some special characteristics to this particular cave. And if I wanted to, I could go prefix equals Addison, which would apply a virtual prefix ahead of each one of the station names that follow that point in the command tree in order to get rid of station naming conflicts. But I'm not going to do that. So I've just compiled this project, which has 339 kilometers in it, and I'm moved here to look at the geometry tab. And the geometry is where you find out how accurate your survey is and where you track down your errors. And one of the great strengths of WALS is the tools available to track down survey errors. And WALS uses a least squares method of loop adjustment. And that is a statistical analysis of the data where the data all of the survey data are compared to each other, which is pretty much all you have in a cave survey. In cave surveys, you do use GPS units or maybe something else to fix the coordinates of your entrance station. But after you get to surveying underground, you're totally relying on the accuracy of your survey instruments and the skills of your surveyors. Every shot you get farther away from that entrance station, the less accurate the location of any station is going to be, because you will have errors no matter what, since we don't have GPS underground. So there's all kinds of sources for errors in cave surveys. What WALS does is it analyzes loop systems. So whenever we have closed a loop in a cave survey, we've gotten station 1, 2, 3, 4, 5, 6, and then maybe 6 goes back to 1. So you've got this loop closure, and WALS adjusts loops and loop networks using the least squares method. And so the more loops you have in a loop system, the more data that is available to analyze and to try to track down the bad loops. WALS focuses on tracking down bad loops. So it's when I compiled this 339 kilometer project, it's going to show me the worst loop closure first and draw my attention to it. And it gives you a statistical value called a unit variance estimate for the horizontal and vertical components of your system. So up here under loop systems, we've got a UVE horizontal and a UVE vertical, and they're given for each loop system. And then isolated loops, and then a total big number down here in red. So this project here with 339 kilometers has a horizontal UVE of 4.03 and a vertical of 3.56. That is the accuracy of this data set. So somebody posted earlier today, just an hour ago, how accurate are your loop closures using a Disto-X? So in walls, loop closed, I hear people talk about my loops closed to within 1%. Well, walls doesn't use percentages. Walls uses unit variance estimates. And the smaller these numbers are, the more accurate your system is. Right now, the screen we're seeing here, again, it's pointing out the worst loop closure, which is a loop here that has 5 vectors. So I'm going to take a look at that and try to figure out what's going on with that. And the way I'm going to do that is to disconnect that loop. I'm going to float it. I'm going to float with the horizontal component and have a look at it. So I'm going to click on float H. And when I did that, it improved the UVE of the whole 339 kilometer project. It changed it from 4.03 just by disconnecting this one loop. It improved the accuracy of all stuff. So I floated that vector. Now I'm going to hit zoom, and it's going to show me what the problem is. So this is a loop. The closed is shown in red. So that's what we forced it to do. But when disconnected one end of it, it doesn't look anything like that. So obviously there's a big error in there. This is not an error that I've been able to track down because it wasn't a survey and haven't been to the cave. But since I connected that loop, I can actually use this button up here and toggle the connection point and have a look at that and try to see if I can figure it out. Again, this isn't one I figured out before, been able to figure out so far, but it's an example of how you float and unfloat. In order to look at something, before I leave this survey, so the person who was asking about accuracy of loop closures in Disto-X, well, the Disto-X is awesome. I'm going to show you within this container project a cave here called Sistema Cantana. It is almost 3 kilometers long, and let's see. Actually, this one includes some dive survey, not to trash my diving buddies, but I'm going to detach that. So we're just looking at Disto-X surveys. Now, so here we have a system here has 20 loops, and it's got a horizontal UVE of 2.15, which is great. Sometimes they get below 1 even. To go back to looking down loop errors, I'm actually going to open up one of my buddies' projects here. He may be out there listening. Sorry, Jason, using you as an example. But I'm going to look at this cave here because it has a good example of one of the tools that we have here. So again, the worst loop closure is coming up. It's actually the worst loop system, which has, if you look over on the right, it's got 6 loops in it. It's highlighted. The first one is the worst one. I'm going to float it, disconnect that loop. Now it's made the whole overall system better, and I'm going to zoom to it. And this is a great example of how you use that disconnected loop to track down what the problem is. So again, the red is where we forced the loop to go, and the yellow is where it wanted to go. Well, it becomes very obvious that GC3 should not have made to connect to GY8. It actually connects to GY9. So if you make that change, you end up with a great loop again, because you can see how close that error is right there between these two. So before you go and put the effort into drawing your cave map, you want to track down your survey errors, get your data in as good a shape as you can before you go to all the trouble of drawing your cave. And so you do that by looking at your loop closures and just start with the worst ones, fix those worst ones, and get those overall that overall geometry down as small as you can. This one here, this number 28, and this number of 19 for your vertical. Those are big numbers. Expect out of that project. I'm going to go back to this one we were looking at earlier to talk about. I know we've some cave divers out there, and dive surveys are entered in a different way than dry surveys. So this again, here's a typical dry survey. Fine. Typical dry survey with from to station names, distance, azimuth, vertical. Well, when you go to a dive survey, you're no longer using a clinometer. You're no longer using inclination. You're using water depths. So I'm going to open a dive survey. And the difference is, well, a couple of things different. One is that in the units command line, there's a section called tape equals SS. And that means station to station. And what that does is it shows you the from depth and the to depth of the stations. Enter this data also was entering in feet, rather than changing the command line to feet, he just left it meters and put F after the distance. So this line here means that station was 1 to was 2 is a 22-foot shot at 52 degree azimuth. The depth below the water surface of was 1 is 2.9. The depth below the water surface of was 2 is 2.2. And it also has some words in this next line. So L words are a pointy bracket, left, right, up, down, and then another pointy bracket to close it out. In this case, you're only recording left, right, so the dash dash means no data. So in the case of a dive survey, you will notice that was 1 to was 2, the depth of was 2 is 2.2, so the next line, was 2 to was 3, needs to start with the same depth, because that's the depth of station was 2. And in the case of was 2 to was 3, you could see that the difference in elevation between those two stations is 1.8 feet. And walls will actually give you an error if your survey shot is 1.8 feet, but you said the difference in depth was 1.8 feet. So that error happens. I've imported a lot of dive survey data, and occasionally that error comes up. There is also in this command line, there is a UVH command. What this is, this applies a weight to a survey. How much weight is a survey going to have in loop closures? In this particular cave, we have dry surveys done with Disto-X, and then we also had some underwater surveys that provided additional loops back to the dry survey. And we knew that our Dist2X survey was going to be more accurate than the dive survey. And so we didn't want the dive survey to distort the dry survey. We wanted the dry survey to have priority about the locations of those connection points between the underwater survey and the dry survey. So we put this high UVH in the command line that basically is going to give this dive survey a very weak influence or no influence on the loop closures of the loops that it's connected to. Hope I expressed that clearly. So you can give different weights to different surveys within a loop system. And another place that comes in useful is in your fixing your entrance station using data derived from a GPS unit. So I'm sure most of you know that any test reading that you take is going to have an accuracy that depends on the abilities of that GPS unit that you're using. If you're using your phone or you're using a simple handheld consumer unit, maybe your GPS accuracy is going to be 5 meters. If you're using a high dollar unit, obviously it's going to be much better. But let's say that you have a cave that's 100 meters long, and you fix the entrance coordinates, and then it has an entrance at each end of that 100-meter long passage. You have a 100-meter long through trip, and you fix the entrance coordinates to both of those entrances using GPS coordinates that have 5-meter accuracy. Well, your survey is actually not going to look very great because your survey is probably over 100-meter distance is a lot better than 5 meters. Your cave survey is, but you've pushed that. You've basically closed the loop because you're putting a fixed coordinate at each end, and you've introduced this error that you didn't need to have by having that 5-meter distortion of your survey locations. So there's a couple ways you can avoid undue influence of GPS units in your survey accuracy in a big cave system with lots of entrances. One is you could space your fixed coordinates out. Even if you had an entrance every 5 meters, you might not want to fix coordinates for those until you get a few hundred meters away from a previous fixed coordinate so that your GPS coordinates don't unduly distort your cave survey. Another thing you could do is you could assign weight to a fixed coordinate. And I don't think I've actually done that in the manual, but it would be similar to this where you would say, I'm not going to give this fixed coordinate 100% power to manipulate my survey. I'm going to give it less than that with the deviation.
Peter, could I ask some?
Yeah.
So I know that
Go ahead,
UV means the horizontal weight. So for a dive survey, would it be better to weight both the horizontal and vertical? Or
it could well be. Yeah, that's
okay.
a good point. I haven't examined that.
Okay, cool.
So that's a little bit about dive surveys and about weighting surveys. Unless anybody else has a question at the moment, I can move on to a few other topics. A couple other things I wanted to talk about tonight are importing files from Compass and also exporting shapefiles. Let me try importing a Compass file here. I'm going to go import this Mac or DAT file. Let me do a little quick looking around here, find out where some files are that I can import. Pardon the silence here, just searching around files. Okay. I don't do this too often, so we'll pick one out here and see how it works. It says Mac or DAT file. I'm try a DAT file here. Okay, so it looked like it worked, and now I have a new cave here. I'm going to compile it. This is Three Fingers Cave. Just a note here about this little warning that came up. It says some non-fatal errors were during compilation. Would you like to review these? And I'm going to hit yes. So it compiled. And typically these are warnings, say like front sight, back sight warnings, that they exceed 5-degree error, which is a default. You can also set that default to 1 degree or whatever you want to. This is where you would get a warning, a list of stations that exceeded the front sight, back sight variance that you've set yourself. In this case, it had some problems figuring out what if the LWUD applied to the from station or the to station, I believe. At any rate, we have a data set here that got imported from Compass, and developing this import routine was not easy. I know that David McKenzie spent a lot of time on it, and I don't know anything about how the data were set up in this project, but whenever you import data from another program, you look at it carefully and see how things were set up. For example, the geographic reference probably ought to be reviewed. Another thing is that as you saw in other cave projects, other walls projects, this Three Fingers Cave has a whole bunch of survey files, and each one of these survey files has a name that was assigned by the conversion program that imported Compass data to walls data, and it gave this survey file that's probably the 16th file in this project. So it's called number 000-016. That's a default naming system. If you were to add these data to an existing walls project that had previously had some Compass data imported to it, now if you were to grab all of these files in Windows Explorer and dump them into a folder where you already have a bunch of data for your project, you may already have files named this if you did a previous Compass import, and you can inadvertently overwrite those old files and lose some data that way. That's something I learned. So pay attention to the fact that Walls has given arbitrary names to these files because they didn't exist in Compass, and that its naming system gets repeated every time you open a file. So, or every time you import a file. So be aware that there's a potential that you already have files named as if you've done previous Compass imports, and that there's a danger you could overwrite those files if you're moving files around. So basically, it was really quick to import that Compass file, and then then you have walls, and then exporting data from walls. There are, I'm not sure how Compass imports walls data. I don't think walls exports to Compass, so you have to Compass to import walls data. You can also import walls data in Andy Edwards' breakout program. And Andy, correct me, but I think you can either import walls data from within Caveware, or maybe you do that via breakout. Can you answer that question, Andy? If you're
I made the import for Caveware. You can import straight into Caveware. Although, yeah, we need to fix up some things and try to get it to where all these programs are using the same exact routines to import the walls data. Because there are some edge cases where it misses some things in Caveware, I think. So.
Yeah, so all these programs do different things, and importing, exporting presents a lot of challenges. I think I will. Let's see. I'm going to do a little bit of GIS export here. I'm opening Google Earth, which unfortunately takes a really long time to load because of how many place marks I have saved in it. So it is actually, I'll also take it over my screen here momentarily. But walls export shapefiles, and which is great because we need that. And in Google Earth Pro, you can open shapefiles. Google Earth then stores files as KMZs, and you can export KMZs. So it isn't a straightforward process to do that. Go back to Compass, to walls here for a second. I'm going to go back to my Quintana Roo project here. And again, this is a 339 kilometer long project in some hundreds of caves. Let me just go ahead. I could export the whole thing, but let me just go ahead and pick one of the bigger caves, which is Rio Secreto. And I'm going to export a shapefile. I go to segments, and I go to details reports. I go to shapefile, and here I want to know, do I want to export all of these things? Vectors, stations, flags, which are like notes that you apply, like entrance or sump or something like that you can put in each vector line. And then wall outlines. So wall outlines is passage walls that you have brought in via round tripping from an Illustrator file. In this case, I'm just going to export vectors. When you do that, you want to pay attention to where this shapefile is going. So I've just created a shapefile, and if Google Earth is ready with that, when it is, I'll be able to import that. I can also talk a little bit about round tripping. I think we're going to talk about that in a subsequent presentation, but I'll touch on it a little bit here by bringing up a PowerPoint that I use for that purpose. This is a graphic that's included in walls that shows what happens during round tripping. So in any big cave system and even smaller cave systems, the survey data are constantly changing. You're adding shots, you're adding loops, you're changing GPS coordinates, you're fixing errors. And if you've already started drawing your cave map and you find this an error, then you've got a problem if you haven't set up your data in round tripping format. What round tripping does is it relates all of the features you've drawn in Adobe Illustrator to the closed survey station. So basically, in this example here, there's these breakdown boulders, this floor drop, these station symbols are all georeferenced relative to the nearest survey station. So if this survey loop was found to be bad and then corrected, then with round tripping, you reprocess not only your survey data, but everything in your drawing, and you move or morph those objects to the corrected locations of the new loop over here. In these examples, you could see that the passage walls moved and changed shape. So did these breakdown blocks moved and changed shape. However, these drop symbols and the cross section, they only moved, they didn't morph. So you control that with the way the wall sets up layers for you, Adobe Illustrator, when you do an SVG export out of walls and you open up that SVG file in Adobe Illustrator. Round tripping between walls and Illustrator uses the SVG file format as an intermediary to do the handshaking and interchange between walls and Adobe Illustrator. Adobe Illustrator doesn't know anything about walls, but walls knows about Adobe Illustrator. So I definitely recommend setting up all cave surveys and maps as in the round tripping format, because what that gives you is it gives you a living map rather than a static map. It gives you a map that's completely referenced. And my little graphic that I made to illustrate that is that if the passage walls are like your skin, and the floor details like your muscles or whatever, when your leg moves, or when your arm moves, the bones in your arm move, you want the rest of the body to go with it. And if you're not drawing your cave map in a round tripping format, your body will get left behind. The cave will get left behind by the line plot potentially. You'll end up with a survey line that's outside of your passage walls. And when you go back and fix all those things manually, it gets to be a real nightmare. And that's why round tripping works well. I'm gonna, Google Earth crashed on me. Okay, I was gonna show you about how to open up that. I'm gonna go ahead and start Google in case it comes back up again here sometime soon. But in Google Earth, you would just open up that shapefile that we exported from walls, and your line's going to show up on Google Earth, and it's going to be an item in your temporary items part of the Google Earth tree. So you can open up a lot of data, a lot of your cave data in Google Earth that way, including the passage walls, and maybe someday the whole cave map, since the whole cave map is georeferenced if you're using round tripping. I think that about covers the topics I wanted to talk about tonight. Now, you probably heard that the round tripping function only works with the plan in walls. The reason for that is walls is just looking at the plan view as far as identifying which station is closest to the different elements in your Illustrator drawing. So, for example, there's a breakdown or something. Go back to the PowerPoint here. In this example, it moved and morphed these two breakdown blocks relative to their positions to the nearest stations. Now, if you had a lower level that was 20 meters below this, and there was a station closer to those breakdown blocks, it would glom onto that station to adjust, but that's not what we wanted to do. So
I think you're trying to share your screen, but we don't.
We're not seeing your screen.
Oh, sorry. That's right. I forgot to tell it that I wanted to share this one. So round tripping, I stumbled onto two questions here, but in round tripping, your plan is going to run into some snags if you have multiple levels of survey crossing under each other. The way you deal with that is you separate those out into different files, and I'll cover that when we do round tripping thing next week. But as far as profiles go in walls, if you want to bring in a line plot for your profile, let's see. Let me find something simple here. All I would do then is click on Profile View. If I like this view, I'm going to set the scale, which that's one thing that, I guess I should have gotten to that earlier in this program, but setting, plotting caves and setting your scale, that's what you do in this dialog box. And I'm going to export this profile at 1 to 250 for 1 centimeter, 2.5 meters. I'm going to, I don't know exactly what frame size I want. Again, I apologize. I should have covered this topic a little earlier, but this is how, either in plan or profile, if you're going to print something or export it, you're going to set the scale and the frame dimensions. So this little bit of profile, if I bring it over to my Illustrator drawing, I can't export an SD because that wasn't enabled, because morphing, round tripping of profiles was a feature that was not gotten to in walls. There's a lot of those capabilities over in Caveware. But so what I do is, if I want to bring in a line plot of a profile, I just go File, Export, Map as Meta file. So that's going to export a Windows meta file, and I would have had to pay attention to where that file went to, where it was saved. But that Windows meta file is a line plot that you can then place in an Illustrator drawing. And I do that with larger profiles that I have. That I don't generally leave those line plots in my Illustrator file, but I use them to line up my various scans, because if I've made a pencil drawing that I'm drafting from an Illustrator, I may have scanned that in several pieces, and I need to align those on the profile line plot. So that's how I export a line plot from walls as